Let's see. Effort, grade, all that shit. All right. So let's see here. Square root of 36.
6.
6. Cut G12 in half. Do you really need absolute values?
No.
No. If you put them there, I'm just going to put a note. I'm not going to take points off because it doesn't change the answer. But see how G to the 6 can't be negative?
Yes.
So you don't need absolute values. If you put them, you're okay. What about this guy? Cube root of negative 8, we've done many times. Negative 2. Cut W12 in thirds. And that definitely doesn't need absolute values. Absolute value makes that wrong. It's an odd root. He's laid back. He can handle all kinds of shit. C, we did one just like it earlier.
X to the 4th.
So if you factor the inside, you should get x minus 4 squared. The square root and the square kill each other. And real quick, please just deal with me for a second. I'm like, that's all I've been doing the whole semester. Square root of x minus 4 squared. What's the square root in terms of powers? Square root is a what power? Square root is a half power. See how these kill each other? 2 times 1/2 is, they kill each other?
Yes.
Do you see how these kill each other? Boom. That's why the square root and the square kill each other. And the 1/2 power makes it a lot more obvious, which is why I wish we had never invented root notation, but too bad for Jack. But what's the answer? Not this.
Absolute value.
The absolute value of x minus 4. I have a shirt with the word vodka in absolute value symbols. No? I came up with that. I searched it. Somebody made a shirt. I'm like, I got to buy that shit.
If it's the absolute value of x minus 4, how do you say negative 8x?
Say again.
If it's the absolute value of x minus 4, how do you get negative 8x?
How do you get 36 if this is a 6? Because we cut it in half. We cut it in half.
What is an absolute value saying that everything has to be positive?
No, absolute value is saying that thing at the end has to be positive. It has nothing to do with what was on the inside. The answer to a square root must be positive, right? Okay. Okay. What about this guy? I freak you out with fractions, or you guys realize it doesn't mean shit? What's the cube root of 27?
3.
So that's on the top. What's the cube root of 125? There you go. So it's just 3 over 5. It being a fraction doesn't change anything, really. Now here's the one that I knew was going to be difficult. What the number on the bottom is the root. So I can write this as the cube root is 64, and the number on the top is the power. Now you could put the 2 on the inside. I don't want to do the cube root of 64 squared. I don't want to. As long as you're rooting it and squaring it, you're fine. It doesn't matter what order you do it in. Cube root of 64, you should know. 4. Is everybody cool with this? What's that? Because we have to know how to go between root notation and exponential notation. The bottom of plants is roots, so the bottom of that is the root. Bless you. The top is the power, because it's powerful. It goes to the top. So I get, what is this again? 4 to the negative 2. 1 over 16. Don't be putting no negative 16 shit down there. Negative power means flip. I can't square something and have it come out to be negative. I can't. Not a real number. Okay? What do I do with the powers? Like if it was a squared, a cubed. A squared times a cubed, the answer would be a to the 5th. Right? I add the powers, no matter what they look like. So how do I add 1/8 and 5/6? So I make this a to the 1/8 plus 5/6. What's the LCD? 24. 24, guys. If you did 48, you'll get there eventually. This will be a to the 3 plus 20. 23 over 24. you did 48, you got to reduce it at the end.
Yep.
Yeah.
How do you find 1 over 16? First, pretty.
What is 4 squared? Are you cool up to 4 to the negative 2?
Yeah.
Okay.
I'm just
So what's 4 to the positive 2? What's 4 squared?
16.
So 4 to the negative 2, negative power means flip. Yes. I really... Do you see how 1/16 means you're like 16 in the hole to somebody? You owe somebody 16. Do you see how that's like an owing? 1/16. Do you understand what I mean by that? No? So 4 to the negative 2 should be somehow 16 in the hole. So that's why, and there's another way to look at why it's 1 over 16. Okay. So the same way as part F is the same old property powers we know from before. Same thing with part G. What do I do with powers when I'm dividing like bases? Subtract them. And again, I need LCD. I get everybody telling me the answer to this is 2 over negative 1 or something weird. What did the person do if they get 2 over negative 1 as the power? They just did 5 minus 3 over 4 minus 5. That's bullshit, right? What's the LCD going to be here? Yeah, so this needs a 5, this needs a 4. I get 25 20ths minus 12 20ths, so I get 13 20ths. Is that cool? Part H we had a lot of fun with, but again, it's just remember your rules of exponents. When I have something to a power raised to a power, I multiply, right? So if I distribute this, 9 to the 1/2, x to the 4/3 times 1/2, y to the 3/5 times 1/2. I just multiply that power in. It's called power distribution. What is 9 to the 1/2? 3. And what happens here? That thing you're doing, Jeff? Okay. Yeah. X to the 2/3, y to the 3/10. Done. So when you raise something with a power to a power, you multiply the powers. That never said anything about what is in the power. It just said period. If that's happening, then that's what you do. So real quick, let me show you what would have been another bonus possibility for this. Ah, shit. Back here. What is this? B to the 3m minus 1 times b to the 2m plus 5.
5 plus 4? I mean, 5n plus 4?
B to the 5n plus 4. Because what you do with the powers when you multiply like bases, you add them. It doesn't give a shit what they are. It never did. It never said that. It never said they have to be whole numbers. They have to be nice. No. Do you understand? So the properties can never change in math. If you think they did, you're looking at something wrong. All right, and here's a two of our favorite. Which one of these is really, really quick? B, because it's an odd root. Nothing wrong with the inside, so the answer is all real. What do you have to do for part A? 5x plus 9 has to be, yeah, whatever number that is, has to be at least 0. To have a nice, real answer. And when I solve that, you get x greater than or equal to negative 9/5. Yes?
Could you ever write that bracket?
Oh, yeah, you could do, yeah, sure. So this would be bracket negative 9/5 up to infinity. You want to put it in interval notation? Sure. I like it. I normally don't.
Ask us to do
I normally don't request it on that kind of problem.
Oh, okay.
Yeah. But I totally could. I mean, interval notation should not be that horrendous. It's one quick little step at the end. Supposed to. Now, except for the people that I sort of helped with this, did anybody figure out what to do with the hell with this? What's the square root of something do to it? Square root of something cuts it in half. A fourth root would cut it in Force. So if I cut something in half and then cut those in force, how many pieces do I have now? If I cut something in half and then cut each of those in force, how many pieces do I have now? 8. So watch. The way to do this officially, directly, is to rewrite. See the inside? What's the inside going to be in terms of powers? Y to the what? 1/4. Now there's a square root of that. So that's going to be raised to the what power? The square root becomes a what power? 1/2. See how that's 1/8 so far? And then finally, what's on all that shit? There's a cube root, so what's going to be out here? And what do you do with powers when they're like this? You multiply. So I get 1/8 times 3. 1/3 is 1/24. So if I cut something in force, and then I cut those in half, and then I cut those in thirds, I end up with 24 pieces. That's all that's saying. I love you guys. What did I do? Nothing amazing. How do you rewrite the 4th root of y? A 4th root is also a 1/4 power. That needs to be easy. Yes?
What's the shortcut?
Shortcut is 3 times 2 times 4 is 24. So it's the 24th root. Yeah. And why can I do that? Because of what I wrote over there. That's why the shortcut exists. Okay. Any questions on this sucker here? All right, let's see what time. You guys want to take a break now? Okay. All right. Come back at 10 till. I'll go grab some calculators for this next piece.